Packet pushers.
Hey, welcome to Day 2 Cloud, you amazing human you. I'm Ned Bellavance. With me is Kyler Middleton, and today we are talking to Keith Gregory from Chariot Solutions, all about data engineering. And you might be like, what is data engineering? We didn't have any idea, did we, Kyler?
No, not at all. We learned all about the different data water features that you might see in your job as a data analyst or engineer, like data lakes and data swamps and data rivers, and just a lot of the infrastructure and engineering knowledge that goes into gathering and storing and making the data available for the science team and the marketing team and everyone that might need it.
And Keith has worked on so many interesting projects, and he brings those real world examples to the episode. So please enjoy this episode with Keith Gregory from Chariot Solutions. Well, hey, Keith, welcome to Day 2 Cloud. Can you tell the good folks a little bit about yourself and what you do?
Sure, and thanks for having me on. My name is Keith Gregory, which you probably got from the show notes, and I am a consultant working for Chariot Solutions, which I wear the shirt today. My background, I recently crossed 40 years in the software industry, starting out with the Macintosh just before it was released, which is
Wow.
probably the coolest thing I've ever worked on. And over those 40 years, it's been a journey. The Macintosh real-time data acquisition, where real-time means within a microsecond of when you say something's going to happen, and of course websites at some point. The largest part of my career, though, has been revolving around data, either databases, workflow engine, OLTP, e-commerce, or more is data engineering and data warehouses. Going back to 1992 was my first quote unquote big data project, which I occasionally use when I give a talk to a user group. And if you'd like, I'll give that because it's a great introduction to what big data is.
You said 1992, and I'm immediately curious because 1992, I was rocking a Nirvana shirt and I was angry at the man. So I don't remember hearing about this big data thing.
Okay, in 1992, I used to wear a suit every day. I was working for a financial services company, and we had put together a data warehouse to collect all of the information about our retail customers. And I was recruited to that company from a former coworker at another company who called me up one day and said, "Hey, Keith, we're working on this project that I think you'll like." And we talk about it for a little bit. And I say, "Wow, so what are you using for a database, Oracle or Sybase?" And he laughs and he says, "There's not an Oracle installation on this planet that could handle this.
Wow.
What we have is," at the time, it was only 32 processors, but fairly short order, 64 processors, $3 million, Teradata distributed database engine, something that I ended up calling my personal computer for a while there. And you want to take a guess at how much data we were dealing with?
So 1992, let's say 3 terabytes.
Let's say closer to 60 or 70 gigabytes for our active data set.
That seems so tiny now.
It is. I could run that on my laptop in Postgres, and it probably wouldn't be as performant, but it would work. So big data, the point I make from that is big data has changed very dramatically over time. I look at big data as anything that doesn't fit on a PC. And right now, yeah, you're talking multiple terabytes. There are companies that have petabytes of data. We have one client that has 120 terabytes of data sitting in S3 that they're looking to make use of.
You hit that project and you really got your teeth into, I guess, what you would call data engineering. Is that sort of the ramp that led you to the next however many years of your career?
I think so. So data engineering, I'd come up with my definition of data engineering, which is everything from the source of the data to making it available for your marketing analysts and your data scientists. And at the time, I was closer to the right side of that, working closely with the marketing analysts at this company versus the left side, a guy named Jeff, who he used to joke that he wished he had negotiated a pay of a penny per row coming out of the source data. But that was all IBM channel connection stuff that I have absolutely no idea how to work with.
That's amazing. And the distributed data in the 1990s, I didn't know distributed databases were a thing until I read about Mongo in the late aughts. So that is far before I was aware that that was a concept. That's incredible.
Yeah, it's one of the things that when I first learned about Redshift, it was, wow, it's the same idea that you take all of your data, spread it out across multiple processors, multiple disks, and do a divide and conquer approach. And Redshift took this and packaged it up for anyone who wanted to use it at 25 cents per hour per node.
So you said data engineering kind of lives before the data scientist or the business analyst or someone who's going to be using those types of tools to analyze what's there. So you're responsible for munging the data and making it look kind of pretty. How is that different from, say, what a database administrator would do?
It's in many ways very close, except I think of a traditional DBA as being focused on the operation of a database server rather than on transformations of the data. And that may be largely my background, in which the development team was largely responsible for all of the database application code versus the day-to-day operation of the database server. And data engineering definitely gets into that day-to-day operation. I recently wrote a blog post about how data engineering is more about SRE than SQL.
Hmm.
And the idea that you have data sources, which may be unreliable, you want to get the data into some destination where it can be used efficiently. So you have to understand both what efficiency means from your data warehouse or data lake. I recently did a talk about comparing, actually, I guess it's a year ago now, about comparing Athena and Redshift and how you take two similar but completely different approaches. It's like Douglas Adams and the machine that makes tea. It's the same idea of divide and conquer, but approached in two different ways. So you think about tweaking different knobs for each of those. So that's one part of data engineering, is actually the physical design, table layouts, paying attention to queries when they run so that you can find queries that have a problem. The other part is the data pipeline of getting the data from the source. And it may be that you have some source, some third-party provider that drops a file on S3 on a regular basis. You may have it set up so that they write data into a Kinesis stream. And now you have to take data out of that stream, make sure that it's valid, and then dump it into your data lake or data warehouse. You may have data that isn't anything like the format that you necessarily want. And you have to start making some trade-offs there of, do you load the raw data and then transform? This is the extract, load, transform approach, which is what a lot of people are doing now. Or do you actually write code in the pipeline that's the extract, transform, load, which has been done for 30 odd years that I know of, that you take the data and try and put it into the warehouse in its final form. I personally lean towards the ELT approach, which we could talk about in a little bit. There's monitoring. If the data doesn't flow, there's a problem, right? So you have to have alerting set up saying, all right, are we getting fewer rows? We're used to getting 100,000 rows a day. Today we got 60. Is that a problem? And have some automated alerting to capture that. So it's very much multidisciplinary.
And so Ned and I did an inventory of the terms we have heard in this space, and neither one of us is an expert here in the data world. So we've heard data scientist, data analyst, data wrangler even, but we've never run into data engineer very often. So I'm curious, how do you draw the line between those different roles?
I draw the line at being a consumer of the data versus a producer of the data. Data scientists have a mathematical statistics background, econometricians, people coming out of physical sciences, where they understand modeling of data and seek to get insights from the data. And that is one very big, very respectable area of working with data. It's something that I've never done. Data analysts tend to be people who perhaps aren't going to the extent of doing modeling. Back when I got started, there was the whole diapers and beer idea. Have you heard of this?
I've heard
So,
this, yeah.
This is new to me.
okay, I looked up the original reference to it, and I think it was late 80s in a paper on, I believe it was business analysis. It's actually been several years since I looked it up. And the idea is that for a certain retailer that was studied, the people who were studying their data discovered that late night people tended to buy beer and diapers together.
As a parent of a 2-year-old, I feel like I understand that vibe.
There you go. And that was what drove a lot of the original usage of data warehouses and data analysis, large-scale data analysis. And it can be challenging to do that. Again, I haven't mentioned the name of the financial services company, but we did a project to understand the sophistication of our customers so that we could do targeted marketing at different tiers of customers.
Hmm.
And for the amount of data that we had, and basically having a data scientist work on the regressions of the data, the thing that was most correlated to sophistication was amount of money under management. And there's two ways to look at that. One is, okay, well, that signal just overwhelmed everything else we were looking at. Or two, the more money you have, probably the more sophisticated you are as an investor.
Right. There's a correlation there, but not necessarily one causing the other. It could be that you're sophisticated, so you end up with a lot of money, or you have a lot of money, which has forced you to become more sophisticated.
Yes. Or we were simply missing the signal that would have given real sophistication. And I don't know that we were, because we picked up on a lot of signals, such as number of transactions, such as your breakdown of where you put your money. So yeah, it's limitations.
Right. And you said you're only working with a few gigabytes. Now you would have an embarrassment of data to look at, but you'd still have to try to glean the same insights from it, just at a much higher volume.
Yes. And that may actually be better for you, going to my understanding of model fitting. Having the model parameters adjusted to deal with the higher volume might give you a far better ability to pick up on small signals that are actually valid signals.
Mm.
And certainly today, there's the ability to do that. We have the hardware ability to be able to take large amounts of data and really process it through these models and say, okay, what comes out of this?
And I'm guessing part of that processing is the pipelines that you were referring to earlier, which when I think of pipelines, I think of DevOps, like CI/CD pipelines, because I think that's what Kyler and I typically work with is we're trying to help our developers build software in the CI portion and then deploy that software in the CD. So we're not really thinking about loading in data and transforming it, except for config data for our infrastructure or something like that. So what are data engineering pipelines versus, CI/CD pipelines?
In a lot of ways, they're very similar. So in a CI/CD pipeline, you do a pull request that triggers a build process, produces some build artifacts, which probably get deployed to a test server. In a data engineering pipeline, you might have something very similar where a file from a third-party provider drops on S3. You take that file, run some process, and then storing it in your data lake. One place where things are pretty different is CI/CD, as I said, often goes to test. With data engineering, you are almost always going straight to prod.
Mm.
I know companies that have set up test environments and they don't get used because they don't have the same volume. So people really can't explore their actual queries in the test environment. So if you have like a new data source, sure, you're sending it to prod, you're sending it into the production data lake, you can always delete it. You can always start from the beginning. And that's actually one of the really nice things I had mentioned ELT versus ETL earlier, is with ELT, you capture your source data in as raw form as you can get it and then transform. And when you do that, if you make the wrong transformations, you can always go back. And data storage is so cheap. I guess actually once you get on the scale of hundreds of terabytes, it's not so cheap. But the infrequent access S3 is 1.3 cents per gigabyte per month. So if you get raw data, compress it down, store it as infrequent access, 100 terabytes is $1, $2, $10. Nobody said there'd be math.
Right. In the grand scheme of things, it's not as expensive as storing it in an uncompressed format in the regular access tier. It actually reminds me a little bit of sort of my preference when it comes to recording video and podcasts is I always want the raw file stored somewhere. Even after I have the published artifact, because if I ever want to go back and pull a quote or pull something out, I have those raw files to work with as opposed to ones that have been processed through some effects filters or I've done some tweaking of the video. I want to be able to go back to the original if there's something useful there. And this seems like a similar sort of situation where if I'm pulling the data from the source and just capturing it raw, then I can transform it however I want after the fact. If I'm transforming in line, then I've lost some fidelity there.
Exactly. But you still need to do some level of transformation for use. So I've recently written a series of blog posts about transforming Cloud Trail files.
Okay.
And this was actually prompted by a client that had a lot of very small files sitting on S3. And when you're working with data lake tools such as Athena, small files, or even something like Glue, small files are just kryptonite. It slows everything down. And the reason it slows everything down is it takes, I've done some benchmarks on this, it takes approximately 15 milliseconds to read a 1 kilobyte file off of S3. That's going to an EC2 instance. It takes about 20 milliseconds to read a megabyte file.
Hmm.
Now, if you have a lot of small files, you're going to take 20 milliseconds for every file read, or roughly 50 files per second that you can read. And that's a hard limit. You just can't go above that for a single reader. Now you can multi-thread, or you can do what Athena does and spin up lots of worker processes to read these files and bring the numbers down. But it's still, if you're doing that for every query, you're paying a huge overhead of reading S3. So you want some level of transformation that takes these small files and aggregates them together. And you might just aggregate them together as concatenated JSON as your first pass transformation. And you may keep the original files. You may throw away the original files, but you've got the same data as JSON. And now you can run queries against that much more efficiently. Now, JSON isn't a great data storage. I wrote a blog post years ago called Friends Don't Let Friends Use JSON in Their Data Lakes. So with JSON not being a very good format, it contains no information about what data types. For example, if you have a date field in your data, if you're lucky, that might be an ISO 8601 formatted date with a time zone, or it might be a millisecond since the Unix epoch, or it might be something even stranger. And if you use a query tool to read those raw JSON files, you have to embed the knowledge of what the date format is for this file in every single query you write.
Mm-hmm.
So you want to make a transformation to a different artifact that contains information about that, and maybe also is a little bit more performant. In the data lake world, that tends to be Parquet, which is a data format, came out of the Hadoop project. And I believe it either came out of Meta or Twitter or LinkedIn, one of the three.
Mm-hmm.
And there's a competing large data format, ORC, which came out of one of the other of the three. So these are the steps that go into a pipeline. Is number one, you've got the raw data. Number two, do some light aggregation or transformation on the raw data. Do some light validation on the raw data. To the extent that you are looking at the actual data, put in some tests. Just like you run tests in a CI/CD pipeline, have your tests. Reject the data if it doesn't meet the tests. And here's where we're going to get into monitoring and logging in a bit. But that first transformation removes any inefficiencies. And jumping off, I said I wrote about CloudTrail when it was really something prompted by a client. Of course, I can't write about what our clients are actually doing, but CloudTrail is something that everybody who uses AWS has CloudTrail. Whether or not they've enabled it and actually look at the trails, they have access to it. So they have the ability to say,
They're very difficult to ingest and use and enrich into information. It's just a ton of raw logs.
yes. And it's a ton of raw logs that all change. There is no fixed schema to it.
Mm.
But you sound like you've had a lot of painful experience with it.
I have. I think this is one of those two pizza team problems that AWS, sort of creates is there's lots of teams working in parallel and there wasn't a standardization early on of what a CloudTrail log should look like. So there are a lot of ways that it looks like. There are a lot of standards and that becomes a problem when you're ingesting all of them and trying to make sense among them.
A few years ago, so at Chariot, we have a large number of sandbox accounts that developers work in. And our developers are great people, but they don't often tag what they're doing.
Mm.
So we've had the situation of who started up this EC2 instance? Let's go back to CloudTrail. And we've been capturing CloudTrail basically. I came back to Chariot. We actually have a OpenSearch server where we ingest everything. And I have a Lambda. This is, again, I'm bringing this back around to data engineering because this is the sort of a data engineering pipeline. Is CloudTrail puts a file onto our trail bucket on S3, that triggers a Lambda, which picks up the file. Because the response elements and request parameters are so very different, it applies some logic to flatten those out into separate fields, as well as stringifying the JSON so that you have, again, the source data available, and then writes those in batches to our OpenSearch server, where we can then go in and 6 months later say, hey, that instance you started up, do you really need that? That's actually a very good example of a data pipeline. Is you have this raw data that is hard to use, so make it easy to use.
Mm-hmm. So that is sort of the data pipeline aspect of it. And one other thing that you had put in your notes earlier was polling versus streaming data pipelines, where I guess one is there's just a stream of data coming out. I remember there's something in AWS called the fire hose, right? That's just data's flown out and you're just trying to dip your ladle in and catch some of it versus reaching out and grabbing information and pulling
Right.
it in, right?
I'm going to say not exactly on the fire hose, but we'll talk about that because it's an important part of most pipelines. But yeah, so one project that I worked with was for a regional bank that had multiple databases. And one database was a SaaS product that you could get extracts of the data by making basically RESTful calls to the database. One database was an actual Oracle database we could connect to via OCI, I think is the Oracle connection interface.
Mhm.
I worked a lot in Oracle in the 90s, and this was the first time I'd dealt with it since then. Mostly used Postgres recently. So that's the sort of polling, is that midnight, we go out and get the day's transactions from these two different databases. And they come back and they get stored in S3 as Parquet, which has a schema, and then as a separate step in the pipeline, pushed into a Redshift warehouse. But again, storing the original data and then reading it into Redshift and so that it can be used easily. Versus streaming, I'm not sure if you're familiar with Twilio Segment.
No.
It's a SaaS product. Twilio is, I don't know everything they do. I know they do email marketing. Segment started out as a separate company that was bought by Twilio that is basically capturing clickstream data. So when you're using your app or going on a website, everything you do is being recorded and being written out as events.
Mhm.
And Segment was basically a place that you could write events to, and then it would send them back to you in various forms. And the streaming part of that was you could set up an AWS Kinesis data stream, and it would write the events whenever they arrived, and potentially thousands of events per second or tens of thousands per second for a busy app.
Right.
So you have to react to that. And there's a couple of ways you can do that. One is that you set up Kinesis Firehose. And Kinesis Firehose, so I don't know if you've noticed this, AWS seems to reuse names an awful lot.
Yeah. It can get kind of confusing after a while. It's like,
Right.
what does that thing do again? I just don't know.
The Azure names are literal and the AWS names are like Greek gods and rocks and stuff. And like, can you just tell me what it does, please?
I find that they cross brand a lot. So you have Kinesis Streams, Kinesis Firehose, and Kinesis Video Streams. Oh, and Kinesis Analytics, which has since been renamed to something else. And they have very little in common. Kinesis Streams is basically a distributed stream, which is just data that you can have multiple consumers. It's sort of like a pub sub, but it retains its information. So Kinesis is basically streaming events. Well, things like Redshift don't want to have data streamed into them. Redshift wants to take a chunk of data, store it internally. Elasticsearch, same way. Elasticsearch will accept individual updates, but it much prefers a batch update because that cuts down on the housekeeping it has to do. So Kinesis Firehose will let you take a stream coming off of Kinesis, or I believe Kafka, at least the AWS managed Kafka. It accumulates that data and then writes it to some destination. So it'll either send it to Redshift or to OpenSearch or to just S3. So you can write your files, you get a stream of data coming in, and Firehose aggregates that data and writes it out as timestamped files to S3, at which point you might have something else that takes those files and does some processing on them. Maybe that's part of your ELT pipeline, is that in SQL, you have these raw files containing JSON data. Now you pull out the fields that you care about and store it as a different table. So that's kind of the difference between the streaming. It's all at one end, the same thing, right? You're getting files and you're putting them in a database, either a data lake or a data warehouse such as Redshift. It's really the polling versus streaming is how you get that. And polling, of course, has more places it can fall down. Most of them your fault, but also the fault of the provider. Streaming, it's more the fault of the provider or whoever upstream is sending the events, because once the data gets into Kinesis, we all pretend that Amazon will always be up all the time and everything works. One of the nice things about Kinesis or Kafka is that it's replayable. Once you put data into Kinesis, it has a lifespan. By default, 24 hours, but you can increase that up to, I think, 2 years, 7 years, some number of years. So that, let's say that you have a bug in your transformation programs. You can reset Kinesis to say, okay, I'm going to throw everything away that I have stored. Let's start rereading from this point and reprocess everything from ground zero. So that's one of the features that Kinesis or Kafka gives you, is that history and the ability to replay.
That's really neat. And could you also do that replay without throwing everything out and just send it to a different destination if you were testing out a new, transform?
Let's pause for just a moment to tell you about Human Infrastructure and Packet Capture, 2 weekly Packet Pushers newsletters you can subscribe to for free. Human Infrastructure delivers informative technical blogs, links to tech resources and tools, plus IT news stories and new product announcements, all with commentary by the Packet Pushers. There's also Packet Capture, a weekly digest of everything the Packet Pushers have published over the past 7 days, including podcasts, blogs, and YouTube videos. It's an easy way to find the episodes and content you want. Sign up for one or both for free at packetpushers.net/newsletters. We don't sell or share your email address with anyone. It's just between us.
Oh, not even testing out. We had an online gaming client, and we've written this up as a blog post, that we had the stream of clickstream data from their app and also from third-party providers that included information about the actual bets that people were making. The gaming industry is really kind of fascinating, and all the regulations and the rules about what can live where.
Mm.
And so the data about the bets coming in, we were dumping that into the data warehouse so that people could do data analysis on it. But then a few weeks before the Super Bowl, one of the marketing team, the request filtered down, we would really like to be able to get a live stream of bets to see which way the odds are going and whether we have more exposure. So I'm going to kind of digress a bit, and I'm not an expert on this, but the idea of a sports book, how sports books make money, is that they expect to have about the same amount of traffic on both sides of an event,
Mm-hmm.
and they take a little bit off the top. So if everything works well, people bet the same amount on both sides of the event. The sportsbook takes its profit, and one side doubles their money, the other side loses their money.
Right.
And there's a whole lot about sportsbooks that can create their own odds, so they adjust the odds to ensure that's happening, so that if you get more money going into one side, they'll change the odds so that that pays off less. Or you get external odds providers that they're setting the odds, so the sportsbook has to take other means. So you get Tom Brady against Patrick Mahomes in the Super Bowl. I believe that was the matchup. You're going to have a lot of money going one way or the other. And normally, business analysts, you look historically. What happened yesterday really doesn't matter. Leading up to a big game like the Super Bowl, it really does matter. And if you can't control the odds, you can't change the odds to make that work. But if you know that you're getting more people betting on one side or the other, you can start running some promos that say, hey, we'll give you $100 of free cash if you bet on this side of the game.
Hmm.
So there is a case where we had this data stream that was sending data into the data warehouse, and we spun up another tap on the stream and its own little database that just kept track of details about this particular game.
I like that idea of you're just adding another tap and you're diverting the data that you're transforming in a different way to a different target.
Yes.
And it sounds like it was pretty easy to implement given these tools. That's amazing.
I'm going to say yes.
Or maybe you just made it sound easy.
I think we had built a solid enough framework that it was easy to implement. So, the implementation was an AWS Lambda that gets invoked off the stream, and then it's just Python code in that Lambda to say, do I care about this? And if I care about it, write it out to this database. Again, this is where there's a lot of SRE and DevOps involved. And I've written an awful lot of Terraform and CloudFormation as part of data pipelines. But you have a Lambda, you have the permissions for the Lambda, you have a Postgres database running in RDS. So to get this to work, it's first, okay, put together the pieces, spin up all of your infrastructure, now drop your code in and let it run. And do it far enough in advance that you're actually testing again with live data. We've got this live data coming off the stream. There is no test data in this. It's all production. Let it run. And verify that your marketing analyst can do a different connection string for Tableau, and boom.
Okay, I have to ask about two words that I hear thrown around a lot. One's data warehouses, and the other one is data lakes. And like I have this idea in my head, and you can tell me like how far off base I am. Like to me, a data warehouse, where a warehouse is like organized and structured, and you got shelves and places where things go. So I think of that as having a well-defined schema and organization. And a lake is just like dump stuff in a lake. It's just a mishmash of unstructured stuff living in this big repository, whatever form that takes. Is that largely correct, or am I missing something here in the conversion of the analogy?
That's pretty close to how I think of it too. I think of data warehouses as being traditional databases, such as Redshift, such as Teradata, such as Postgres for that matter. And it's just size. So I think that's pretty much how I think of data warehouses as well. Data warehouses are, in my mind, traditional databases, such as Redshift, such as Teradata, such as Postgres for that matter, where you define all of your tables and fit the data into those tables. And yes, data lakes are often a place where you just dump semi-structured data. But to make a data lake usable, you have to have rules for how you access that semi-structured data. And especially with the rise of tools going back to things like Hive, which is a SQL interface on top of Hadoop, or Presto, which is underpinning for AWS Athena. To use data, you really do need structure to it to make sense of data. So part of the process of making that data useful, sure, you get data in from many sources that may be semi-structured, and then your pipeline transforms that and makes it far more structured. But you still have in the lake the semi-structured data, and you might write custom code that says, I know that we have in this particular data some things that we should pull out. Let's write custom code to go through and just extract that. So again, it's using the same data for multiple purposes. And one analogy that I've been trying to fit into a blog post, but it's a very tenuous, more metaphor than an analogy, is the idea of a data river.
Okay.
And I kind of came up with this after reInvent a few years ago, standing back of the Hoover Dam and thinking, wow, that water's pretty low. I don't know if you've been out there, but the water is down dramatically from where the level in Lake Mead should be. And there's branches of Lake Mead that used to be marinas and are now dry land. But the idea is that the Colorado River has a whole bunch of lakes in it, and they all serve different purposes. So to the best of my understanding, I think it's Lake Granby up on the Colorado Plateau. Is basically flood control, capturing the runoff from the Rocky Mountains. And the Colorado River leaves it, goes through several other lakes whose name I can't remember. And by the time you're getting down into Arizona, you have Lake Mead, which is irrigation, hydropower. That's where the Hoover Dam is Lake Mead with irrigation and hydropower. Then you go down into Lake Havasu, which is largely irrigation for California's Central Valley. They all have different purposes. And I think of data lakes in that way as, yeah, you dump the raw data in, but then you're going to be pulling out data, transforming it specific to a purpose.
Hmm.
As I said, it's a rather stretched metaphor, and I really am trying to figure out how I can write about it.
Well, we can just confuse metaphors even more. And the other one that I hear is a data swamp. And I guess that's when you haven't done the work
Yes.
to properly structure things.
Yeah, well, swamps lead to rivers, or lead to streams, lead to rivers, lead to lakes. So maybe things have to start out as swamps. The trouble with a data swamp is that you put data in without really thinking about how you're going to use it, and it just kind of sits there and festers. We could take this metaphor pretty far.
I guess we could. You had mentioned that you wanted to also talk about business intelligence and OLTP. So, how does that factor into the larger conversation we've been having?
It's two very different mindsets.
Hmm.
So OLTP, online transaction processing, is the database that sits behind your line of business systems, right? So your e-commerce system, you're going to have an OLTP database. I often use banking systems because everybody is familiar with working with a bank, right? That has accounts, it has transactions. You go to the ATM, you withdraw money, that's a transaction. And the thing about OLTP systems is that they deal with only a few rows of data at a time. Okay, so you go to your bank or your ATM, take money out, that's one transaction. Maybe it goes out to the bank's OLTP system, looks up your account details so you can see the balance, then writes a transaction that says, okay, $100 withdrawn from this account. And you may have thousands of people doing this at the same time, but they're all dealing with only a few rows. And an OLTP database system is optimized for that use case. So for example, a B-tree index, which is an index where you basically work your way down through a tree of values that start with A are here, values that start with B are here, values that start with C are here. So you can find out that Keith, as you go down here, and you can find my information. The difference for a business intelligence database, which is how I tend to refer to them, a lot of people use the term OLAP, online analytics processing,
Yeah.
but I think of that, and may just be me, as more the idea of a star schema where you have fact tables and you're basically doing a scan of a fact table. And we can jump into that a little bit. But the more general business intelligence systems, such as Redshift, such as Athena, are going to be doing what look to be regular relational joins between two tables, but touching every single row potentially in both of those tables. And it's just a completely different approach to dealing with your data, right?
Right.
You can be optimized for single rows, but if you take a 100 million row table and join it to a 10 billion row table, traditional database systems, this goes back to my former colleague saying there's no Oracle system on the planet that could handle this because it goes against what Oracle or any other OLTP database is designed to do,
Mm-hmm.
and leads to a couple of architectural differences between the databases. So I've talked about indexes on OLTP. With a business intelligence data or business analytical database, it's all about divide and conquer. It's all about taking your gigabyte or terabyte or petabyte and splitting it up into a lot of files or whatever. Redshift uses, it looks like a regular table structure. Athena uses Parquet or another readable file, and sending out lots of workers to do the work.
Mm.
So Redshift, for example, you can configure Redshift cluster with a certain number of nodes, or Redshift serverless has Redshift processing units, which are all independently doing work. And the idea is that you spread up your query. So let's say you want to find all of the transactions for my account, and you may have a billion transactions in your database. Well, if you take a billion transactions and have those all stored on one physical disk, even an SSD, and have one physical CPU reading them, it's going to take a long time.
Mm-hmm.
But if you have a dozen CPUs, or actually let's make the numbers easier. If you have 10 CPUs reading, now you're only dealing with 100 million per. 100
Right.
CPUs, you go down to 1 million rows per, and it can execute very quickly. And the same thing when you're doing a join is, as long as the data is co-located on the same physical device with the same physical CPU, joins happen very quickly. There's what's referred to as a sort merge join, where you take all of the, or a hash join is similar, where you take all of the rows that you've selected from one table and go through the second table and basically scan the entire table to find the rows that match. And there are many different ways to do that. One is hash joins, as I said, where you basically say, okay, this key value that I'm joining on, I'm going to hash it, which means turning it into some representation like a SHA-1. And then I'm going to use that. I've extracted all the rows from the table on the right side of the join, hashed them. I'm going to probe the hash table to find the matches.
Mhm.
And that seems like it would be a tremendous amount of work, and it would be, except the business intelligence databases have one other optimization that they often use, which is called columnar storage. So in an OLTP database, you put all of the fields in a particular row together. So you read your row out of a disk block. With columnar storage, it breaks it up so that all of the ID fields are in disk blocks together. All of the name fields are in disk blocks together. All of the transaction amount fields are in the same disk blocks. So if you're just joining, you're not reading the entire table. You're just reading the blocks that correspond to the IDs that you're joining. So it's a lot less data that you're processing.
I remember hearing that columnar database verbiage probably back in like 2015, 2016, when there were, I think, a number of different database vendors that were pushing this idea. And I didn't really understand what it did. I just knew that it was very important for data warehousing and like BI systems. And so I would go, okay, they need that. Well, okay, the data team, they'll take care of that. And I just need to make sure they have the infrastructure to run it on.
Right. Yeah, I have to admit, describing it, I'm thinking, a picture would really be worth maybe 2,000 words in this case. It basically comes down to, well, the core idea of any database is minimize the amount of physical disk activity.
Mhm.
Okay. With a business intelligence database, the nature of your queries is to touch huge chunks of your tables, to maybe take a quarter or a half or even all of a table and join it to another table. You don't care about individual transactions, but you do care about, tell me by bank branch or ATM location, total amount withdrawn, which is a perfectly reasonable thing to do because you can look for patterns in that and say, okay, the ATMs down by the sports complex in Philadelphia get much higher usage on a Friday, so we should plan to restock them
Mhm.
more frequently then. Or this ATM out in, I don't want to offend anyone, so I'll pick a ghost town. This ATM in the middle of Centralia, Pennsylvania,
Good choice.
never gets used. So maybe we take that out of there before it gets swallowed up by the coal mine.
Oh, it's just burning money there. I mean,
Oh,
I'm so sorry.
I suppose one of us should tell people who haven't heard about Centralia. It's a ghost town in the Pennsylvania coal region that in the mid 60s, a fire started in the coal mine
Mhm.
underneath the town, and they couldn't put it out.
Yep.
And it's been burning for 50 years now. And some 20 years ago or 30 years ago, the state finally paid everybody who lived there. I think the population is under 10 right now of people who wouldn't move, and they demolished their houses.
Mhm.
And if you're ever there, have you been there?
I have not been there. I've seen pictures.
It's on one of my favorite motorcycle routes. You have a street grid that over the past 20 years that I've been riding up there has slowly been taken over. It was empty lots and then small brush, and now it's trees, but you still have these paved streets that go off either side of the main road.
Oh, that's super spooky. I wish there was like a data engineering analogy we could use to bring it all home.
I don't know, lighting a fire in your data lake? Yeah.
I don't know. Speaking of taking it home, Keith, we've covered a lot of ground here. Maybe you could just summarize the conversation for us a little bit around data engineering and things that folks like us, DevOps and cloud architects, should bear in mind if they're going to be engaging or want to get into the world of data engineering?
We have another 45 minutes.
Sadly, no.
I think the things that I would like to convey are, number one, there's a definite split between data engineering and data science / business analytics. And it's the data engineering side is the side that makes the data available to the business analytics people. And in a proper environment, there's a lot of play back and forth. So like DevOps is the interaction between the operations team and developers to kind of both understand what each other are doing. That's critical for data science / data engineering. I don't think you can take a data scientist and say, do data engineering, or vice versa. At least I know that you do not want me doing data science. Certainly people can move between the two, but it's two very different skills. The data engineering skill is all about reliably getting data from a source, transforming it, making it available, and making it performant when it's used.
Awesome. And you mentioned blog posts a whole bunch of times. We will include links to where you can find those blog posts. If people want to hear more from you, is LinkedIn the best place, or is there somewhere else that you're socially active?
I'm on Mastodon. I look at LinkedIn very occasionally. So I will give you my Mastodon information. I don't post a lot, but hey, that's just because I don't post a lot.
You're busy doing cool things. Why would you be posting? Awesome. Well, Keith Gregory, thank you so much for being a guest today on Day 2 Cloud. It was fantastic to chat with you. And hey, humans out there, you listeners, virtual high fives to you for tuning in. If you have suggestions for future shows, we would love to hear about them. You can hit either of us up on LinkedIn, me or Kyler. Our DMs are pretty open. We're not scary people. You can reach out, very friendly. Or if you prefer, you can fill out the request form at packetpushers.net/FU. The FU is for follow-up or really anything that you want to say about the shows. Speaking of Packet Pushers, did you know that they have a weekly newsletter? It's called Human Infrastructure Magazine. You're the human and you're part of the infrastructure. It is loaded with the best stuff we've found on the internet, plus our own feature articles and commentary. It's free and it doesn't suck, and we don't harvest your emails and sell them to anybody else. If you're interested, you can get the next issue via packetpushers.net/newsletter. Until next time, just remember, cloud is what happens while IT is making other plans.